This is Module 10.3, Interpreting Equilibrium Constants. So we learned to write the equilibrium expression as K equals products over reactants raised to their coefficients. Since we remember that this is just crudely, we can think of this as products over reactants. We know that if K is a large positive number, then we had to have made a lot more products. If we made a lot more reactants, then we would have a very large number in the denominator and K would be very small. So the magnitude of K indicates whether product or reactant formation is favored at equilibrium. So a rule of thumb, or three of them, are laid out for you here. If the value of K is much greater than 1,000, then product formation is favored. No matter what we put into the flask, we're going to favor going in the forward direction as written. If K is less than 0.001, then reactant formation is favored. The reaction is going to tend to go in the reverse direction to make more reactant. If K is between these two values, then you can have significant amounts of product and reactant are present at equilibrium. So here it's shown to you visually with this arrow starting with a deep blue going to a deep red. We have Kc. This is never going to go negative. This is always going to be a small it's always going to be a positive value. If we're in the blue region, then K is very small. The reaction proceeds hardly at all. If K is very large, then the reaction proceeds nearly to completion. Now, what you have to remember here is this is looking at the reaction as it is written. So forward direction this way, reverse direction, going back towards the reactants. So let's take a look at the type of question that you might encounter on this. Sample question. Consider the equilibrium PCl5 decomposing to form PCl3 plus chlorine. And we're given that K equals 4.2 times 10 to the negative fifth at 125 degrees Celsius. First, you may be asked to write the equilibrium expression. So, okay, we can write the equilibrium expression. Since they haven't told us whether it is a gas or whether we want to express it in molarity, we can do either one. So we're fine with writing that Kc is equal to PCl3 times the concentration of the chlorine gas divided by the concentration of the phosphorus pentachloride, okay? Notice, once again, think of this as products over reactants. Right, so it says, suppose we start with 0.1 molar PCl5 and PCl3 each. So we've got a mix of products and reactants. After the system reaches equilibrium, which species will have higher concentration, PCl5 or PCl3? Well, let's look at this. K is very small. So I'm writing my data down. K is very small, okay? So that means the reactants are favored. Now I'm doing my interpretation or my reasoning, okay? So K is very small, so the reactants are favored. PCl5 will be present at higher concentrations. Remember that we want to do claim, evidence, reasoning when we are answering these essay questions. So first, K is very small. That is my data. They have told me that. So the reactants are favored. There is my reasoning and my claim. PCl5 will be present at higher concentrations. You don't need to do the claim, evidence, reasoning in any particular order as long as they are all there.